Hey everyone, welcome back to our SwiftUI game development series. Today we're tackling our kind of drag gesture survival arcade game. Let's take a look at what we built last time. So we have this kind of game here with some background music. We have some variety of enemies kind of falling from the sky. We want to survive for as long as possible, and if we get hit, then we kind of have this explosion and our game automatically resets. Pretty cool. But what if today we took it to the next level? So in what I'm dubbing as Bulletstorm 3.0, we have added power-ups. So in my game logic currently, they're spawning every 10 seconds. You can see that we have this new shield on the screen. We're gonna navigate to it. Look at that, we have that nice new glow. And watch this, I'm gonna tank the satellite like it was nothing. The satellite disappears. I'm totally fine. Oh, we have another one, the speed up over here. Ooh, the speed up causes the timer to move fast, but also the enemies, I can still dodge it. I've got the skill. So this allows us to have more dynamic enemies. And also, it's a high risk, high reward for the player because the timer increases in speed, which means they can actually gain more points. So these power-ups are spawning randomly. I just got the shield again, and it allows us to really experience our game in a new way, and it allows players to have a lot more fun. And we have a slow down time one. You can see that the enemies fall even more slowly, which makes it easier, but also kind of harder in some ways. So if you are interested in learning on how to add these specific power-ups, as well as the fundamentals to create your own power-ups, let's go ahead and dive on into really taking our game to the next level. So before we get started, you can use the links in the description below to download the previous copy as well as the assets that I'm currently using. You can of course feel free to add your own sound and sprites and things like that. But under my GitHub pages, if you wanted to head over to the SwiftUI projects, if you're ever curious on how to download any of the projects that we make together, just make sure you double check whatever, I usually call it whatever the project name is on Xcode. In this case, we're using SpriteKit and Bulletstorm Revenge. You can just press on this button here and download it. If you want the older ones, you can search Bulletstorm Revenge, right? And you can even watch the tutorials that are all associated with those videos. So if this is your first time joining on in and you want to grab or watch some of the previous segments to get all caught up, feel free to do so. If you want to start where I'm starting today, you'll want to download the 2.0 as we are continuing this build. So what are we going to be covering today? We're going to be adding new power-ups. So in my case, I'm doing the shield, slow motion, and speed boost. And we're also going to improve the game flow management. We're going to be, editing some functions and creating some new ones. So let's go ahead and dive onto the code and make this happen. We want to collect different power-ups. A few things we're going to have to do is create said power-ups. And we're also going to need to handle the logic for when the player collides into them. So an issue we may have with the collision currently is even if we're interacting with a power-up or something that is an enemy, the game kind of all thinks it's the same and it would cause our player to explode. So I'm going to make a new Swift file and it's going to be really short. And this is going to be our physics category. So I'm going to create a new empty file here. I'm going to call it physics category. Wonderful. And this one's going to be really quick. We're just going to make a structure here with all of the different kind of physics objects that we're going to be including. And this way, whenever we go to expand upon this, we'll be able to add them in very easily. So if you have things like power-ups or maybe heals or lives, right, you'll be able to classify these very simply. We're going to do all of these by creating a static let. And for this first one, we're going to have a player. We're going to use the uint32. We're going to set this to be 1. This is basically a 32-bit integer style. We're going to repeat this for our static let of enemy uint32 equals 2. And these are the numbers we've already assigned to the player and the enemy in our previous code. And now we're going to create a static let for our power-up. We're going to conform this one just the same. 32, and we're going to have this one equals 4. This way we have that separation. Next thing we're going to do is create our power-up model. So we're going to be doing a lot of data modeling within this project, which will also help us in case we ever want to create more game modes. We'll be able to take a lot of the kind of data modeling we've used in this current game mode and apply it to any other ones. So let's go ahead and call this one power-up model. And first thing we're going to do is import SpriteKit, just so we have any SpriteKit related gameplay features and that functionality already within there. Next, we're going to make an enum, and this enum is going to be for our power-up type. Don't forget with enums, we can start those with a capital. So this will be for defining the different power-ups available in the game. So let's make a few of them. I'm going to do a speed boost. And even if you want to leave a comment here about what those kind of power-ups will do for yourself later, that's a good idea. So I'm going to say speeds up enemy movement and score clock. I want this power-up to be something that's high risk, high reward. The enemies are moving faster, but you're going to be getting points faster too. Then I'm going to make another one for slow enemies, right? If you're making these cases pretty obvious for yourself, you might not need the comments, but always a good idea to do so. So this is going to slow down enemy movement. Now, just for a note for myself later, this one is just going to be super good, but it could also maybe be a little bit hard to play around. So in this case, maybe I don't want to slow down the score clock, but we always could if you want to. Then I'm going to make a case for the shield. So this is going to absorb 1 hit for the player. So when we have the shield on, if we run into something, it'll destroy the shield, it'll destroy the object, but keep us, the player, safe. Pretty self-explanatory. Next, we're going to create a class representing the collectible items that provide those temporary effects. This is how I'm doing it in my game. You collect the power-up, you get instantly. Maybe you want to store those later and allow the user to choose when they want to use them in your game. It's totally up to you. So let's make a class and we'll call it PowerUp. Super simple. And we're going to conform this to be the SKSpriteNode. Next, we're going to create a variable type, and these are going to be PowerUp type. So these are going to store the types of power-ups. So because we're using class, we should probably include an initializer. So we're going to create an init, and we're going to call it, and within our brackets, we're going to have a type, and we're going to go to that PowerUp type that we had just created. So in our initialization, we're going to have a self.type. And this is going to equal type, and this is going to assign the PowerUp type, right? Whether that's speed boost, slow, or shield. Then we're also going to have our texture, so let texture. This is going to be an SK texture, and this is a variable to hold the appropriate texture. Next, we're going to be using a switch statement here. We're going to say switch type. This way we can have the different cases. So the first one is going to be .speedBoost. Then we can have our different textures here. So in this case, it's going to equal an SK texture, and we're going to have the image named. And for mine, I'm going to call it PowerUp underscore speed. So let's go ahead and copy and paste this so we can save some time here. Might be faster for you to type it out, but it's up to you. We're going to have the second case be slow enemies, and then the third case, we're going to reference our shield, and whatever you have these called. So in case of, I think this one was slow, we can always double check. These are what they're going to need to be called in the assets catalog. So if we go to our assets we created last time, I'll put this link in the description again. I had PowerUp Slow, PowerUp Shield, right? I'm going to select all of these. If you have different file names, you'll need to rename these to reflect what it is in your PowerUp model. So I think we are all good to go there. PowerUp Shield, Slow, Speed. Let's double check our PowerUp model. Perfecto. Cool. Now we need to call the superclass initializer with the texture as well as the default size. So we're going to do super.init. And then within the brackets, we're going to have our texture, and we're going to relate this to the texture, right? Whichever one from the case we're going to have, it's going to pick the correct one. And then we're going to do a comma, and we're going to set the color. And in this case, we're going to set it to be .clear. We're already handling, with our sprites, the color and things like that. So we're just going to make it clear. We're also going to include a size, which is going to be a CG size. And we're going to add some brackets. We're going to have a width and a height. You can set this to whatever you want. I was using 30 by 30 in my example, which is a little bit smaller than our 40 by 40 player. Cool, and now we need to set up the physics body for the collision detection. And just like with before, with like the enemy or player collision detection, in this case, we're going to be referencing a class, and we're going to use self here. So we're going to do self.physicsBody equals skPhysicsBody, and we're going to create a circle of radius. Because my width and height is 30, I'm going to set my radius to be half of that. So we're going to do 15. And this is essentially going to define our collision area. Then we're going to allow the power-ups to move. So self.physicsBody question mark dot is dynamic. We're going to set this one to be true. We want these to be able to move. Then what we're going to do this time is we're actually going to reference the affected by gravity, which is pretty cool. We don't want the power-ups to fall with like gravity. We're going to be using our own code logic to kind of bring them down. So we're going to do self.physicsBody.affected by gravity, and we're going to set this one to be false. Next, we're going to do our category bit mask. You'll notice a lot of the kind of things we're doing here are things we've already done for previous kind of logic in our game, like the enemies. So we're going to do our category bit mask. We're going to set this one to equal the physics category that we've created earlier, .PowerUp. So this is going to assign the category for the collision filtering. We're also going to want the self.physicsBody. I should be really good at typing out physics at this point. !collision test bitmask option on the autofill here. It's going to equal the physics category once again, .player. So we want to detect contact with the player, right? It doesn't really make sense if a power-up hits an enemy, it's not going to empower them. We don't want it to get destroyed. We just want the power-up to be able to be collected and the collision logic to be only associated with the player. All right, we have a couple more to do here. So self.physicsBody ? Collision bitmask. We're going to set this one to be 0. And this is going to prevent physical collisions. It only detects contact. Cool, and now we're going to set the z-axis position. So self.z-position. And we're going to have this one equals 1. Right? I think we had set our background to be like -1 or maybe -10. This is just going to make sure that it appears above the background. Okay, and you can see we do have an error here. There's a required initializer, so we're not going to implement it since PowerUp should always be initialized with a type, but we do need to include the required initializer. So you can either use the autofill there, or you can just type it out. So we're going to do required init. We're going to use our question mark here, coder, a decoder, conforms to the NS coder. Add a brace here, and we'll just include a fatal error. And within the message, we'll say init coder has not been implemented. But we should never run into that because the power-ups are always going to be initialized with the type. So we should be good to go, but we just have to include it for the class. All right, let's head on back over to our game scene. So this is where we've created the logic for our SpriteKit game. And what we're going to be needing to do now is apply the power-ups. And we're also going to spawn the power-ups randomly, making them appear occasionally. If you maybe, every 10 seconds, a speed boost every 20, it's up to you. For me, I kind of like the random nature of the game where it's like, we can't really predict what's going to happen. I find that to be fun. In our variables here, which is kind of near the top of our code, we're going to be creating a couple more. The first variable we're going to be doing is we're going to be doing the shield active to handle when our characters have grabbed a shield and they can absorb a hit. We're going to set this to be false, and essentially this is a flag to check if the shield is active. Next, we're going to add another variable for a PowerUp timer. And this is going to be a timer with a question mark. And this is a timer for spawning those different power-ups. I'm going to set mine to be every maybe 10 or 20 seconds, but if you want to handle yours a little bit differently, feel free to do so. Alrighty, and let's make a function to apply power-ups. Let's call it apply power-up. Now we are going to include something within these brackets, and that's going to help us establish which power-up we are collecting. We're going to do underscore space power-up. We're going to add a colon, and then we're going to reference with a capital P this time. This is why we have created the class ahead of time. So we're going to say if let collected effect equals SKEmitterNode. Then we're going to include a file name PowerUp effect.sks. Sorry, this file name should definitely be a string here. We're going to add a brace here. We're going to have a collect .position equals player.position. So this is going to essentially create a sparkle, which we're going to be making in just 2 seconds around where the player is. And we're also going to have that collection effect .z-position equals 2. And this is just going to place it above elements. We're going to go ahead and add child, the collect effect. Let's go ahead and create that. Just like with our explosion, let's go ahead and right click or use the plus button in the very bottom left. And we're going to create a new file from template. I like to just search sprite in the top right. We want the SpriteKit particle file. So I was using the magic one in my example, I believe. So we can go ahead and do that. We're going to call it power up effect. You can see here that it kind of has these green sparkles as well, which is pretty cool. There's some cool ones that are built in, but you can actually even make your own SpriteKit animations as well. All right, back on over to our game scene. We now need to create a remove action. So we're gonna say let remove action equals SK action dot sequence, and within our brackets we're gonna add our square brackets for an array SK action dot wait. And then we're going to do a for duration. Let's have it be 0.5, and then outside of the brackets, but still within the array, comma, SK action. And we want the dot remove from parent. And then we're going to go ahead and remove that effect. So collect effect dot run remove action. This is going to remove that effect after a short delay. Now, just because we're using an if let, let's go ahead and also add that else statement here, and we'll just print, effect not found. Otherwise, we will have a crash in our project. So now we have this kind of beautiful effect. Well, let's go ahead and now create a switch. And this is going to be for PowerUp types. So switch PowerUp dot type. And add a brace, and we'll add different cases. So the first case let's do dot speed boost. Add a colon here. And the first thing I would suggest is if you have any sound, you can add it here. So sound goes here. So if you want to add like a little effect, like boo boo boo, you got this speed boost or something, feel free to do so. We already have our sound manager set up. Let's go ahead and add an animation to play to indicate that the power up has been activated, right? So we're going to say let scale up equals SK action dot scale 2, and we're going to do the one with a 2 duration. I'm going to set this to be 1.2 and the duration just to be 0.2. I just want to have it kind of scale up really quickly. We're going to do the exact same thing for our scale down. So let's scale down equals SK action dot scale. And we're going to do the 2 in duration. Set this one to be 1.0 because we're kind of coming back down to regular. And we're going to set the duration to also be 0.2. If you find it's too fast, too slow, adjust that duration. If you find you're not really noticing how the increase in size, change the scale. Then we'll have the player.run skaction.sequence with the different actions. We're going to first scale up. So we're going to add our square brackets for our array. Scale up, comma, scale. Wonderful. We're going to then run our skaction.wait for duration. And I'm going to set this to be whatever I want my power up duration to be. So in this case, I'm going to do 5 seconds. So 5.0, we're using time. We should be using a double. I'm going to go ahead and add my brace outside these brackets. And this is where I'm going to change some different properties. So here comes the issue of how do we handle how the enemies are going to be changing speed? That's kind of difficult. So what we can be doing is when we're thinking about how our game's been moving previously, it's been using a game time modifier to essentially say, okay, I want the enemies to spawn, and then within 3 seconds, they're going to reach the bottom of the screen. Well, what if we edited the game time modifier as well as applied a enemy speed modifier as well, to not only change the rate that they're spawning, but also change how quickly or slowly they go from the top to the bottom. So before we continue within our switch, let's go back up to our variables. We're going to create a couple more variables. The first one's going to be enemy speed modifier, and this is going to be a CG float. And this is going to equal 1.0. And this is going to be the modifier for our speed. And let's also make a variable for the game time modifier, which is this time going to be a double, and that's also going to equal 1.0. So this is going to be a modifier for that game time. It's also going to affect the score rate, because when I want the game to speed up, I also want the player to be earning score a little bit more quickly. Okay, cool. Let's go ahead and scroll back down to our speed boost, and right under it, so I'm going to put mine under the sound goes here. I'm going to set the game time modifier to equals 0.5. So this is going to actually update the score twice as fast. I'm going to adjust the enemy speed modifier to equals 2.0, and this should cause the enemies to fall twice as fast. And we're going to have to actually handle that with a couple more functions in the future. So let's go ahead and reference them now. What we're going to do is we're going to restart the score timer, and then we're going to update the enemy speeds. So this one's going to restart the timer within a new rate, and then we're going to apply new enemy speeds, which also means when the power up ends, we're going to have to reset those things back to normal. Cool, so in our run action, now let's go ahead and adjust the self.gameTime modifier. And this is then going to reset it back to 1.0. 1.0. So when the 5 seconds of the power up runs out, we're going to kind of be resetting things. So then we'll also reset the enemy speed modifier that we've changed above, also back to 1.0. And then we're going to self.restart the score timer and self.update enemy speeds. So those two functions we haven't created yet, we're going to be, when we first collect the power up, we're going to be changing those things, and then when the power up runs out, we're going to be resetting those things back to normal. Let's hop out of this run action here, and let's add a new case for our .slow enemies. And for this one, we're also going to be adjusting the enemy speed modifier, but instead of 2.0, we're going to have this one equals 0.5, which is going to slow down the enemies. If you want to include a sound for picking this one up, feel free to do so as well. I'm also going to update that, or I was going to call upon this function here of the update enemy speeds. Again, hasn't been created yet. We'll go through the logic momentarily. That's it for this one. If you also want to have the player kind of like animate and glow up and down, you totally can copy and paste that from above. Otherwise, we're going to go ahead and run an SK action, and that's going to be the .wait for duration. I want this one to also last 5 seconds. Add our brace, and afterwards we're going to reset the enemy speed back to normal. So we want the self.enemy speed modifier to reset back to 1.0, and then we're also going to want to self.update enemy speed to trigger once more. Cool, let's go ahead and make that case for the shield, and then we'll play around with the speed modifiers. So outside of this run brace, we're going to go ahead and create our final case of the .shield. If you do create more power-ups, you would just create more cases. And in this case, we're going to activate our shield. Oh, I spelled it wrong above, so let me go ahead and fix that now that I noticed it. It's not actis, it's active. Wonderful. And this is now going to be equaling true. We're going to essentially activate our shield. Then we're going to create a glow. And I kind of like having that shield around my player. So let's go ahead and create a glow, and that's going to equal the SKSpriteNode. So we're going to be using a circle. So let's go ahead and do circle of radius. We're going to set this to be 25. We want it to be larger than the kind of radius hitbox of our ship. We're going to use this to create a glow effect. So what we're going to do is access the properties of glow. We're going to give it a stroke color. In my example, I'm using .cyan, which kind of creates that light blue color. And then we'll create something with the line width. We can make this as thick or thin as we want. Let's set it to be 4. We can always come back and adjust that. And then we're also going to adjust the alpha. And this is basically the transparency. I'm going to set this to be 0.7. Because I find that having it as alpha as 1 is a little too distracting. Then we're going to have a glow.name, and we're going to call this one shield glow, just so we can reference it. Then our glow.position is going to essentially just be 0, 0, and then we're just going to add the glow to the player child. So this is going to equal CG point. Our X and Y values, we're going to do 0 and 0. And then we're going to add this to the player. So we're just going to do player.add child, and then the node of glow. Cool, and then with the other power-ups, we're going to include a run with an SK action, .wait for duration. I'm actually going to set this one to be 10.0. I want this to be a pretty cool power-up that lasts 10 seconds. If I'm spawning a power-up every 10 or 20 seconds, maybe it's possible to kind of just keep them going, but you can always play around with your balance. So once the 10 seconds is up, we're going to take our shield is active, and we're going to set that to be false. And we're also going to have our glow.remove from parent. If we don't have the shield, then we should remove that glow effect. Alrighty, let's go ahead and hop out of this very large function we made of the applying the power up. You know what, since we're not using the canvas either right now, let me go ahead and hide that just so we can see everything a little bit nicer. And underneath the apply power up, let's make a new function and we'll call it update enemy speeds. Where have we seen this one before? Okay, so this is where we're going to update the existing enemies to use the latest enemy speed modifier. So for node in children, right? So for all of those enemies, if let enemy equals node as SKSpriteNode, let enemy dot physics body dot category bitmask equals 2. So that's what we had assigned in the previous build to be the kind of collision detection for our enemies. Let base duration. We're going to set this to be a time interval, and we're going to set this to equal 3.0. But this is essentially going to be the time it takes for the enemy to go from spawning at the top all the way to the bottom and despawn. So whatever we want our default fall duration to be, I found 3.0 to be pretty comfy, but also in testing 1.0 was super duper fun, so play around with this number. And then we're going to say let adjusted duration equals base duration, and we're going to divide this by the enemy speed modifier. And essentially this is going to create an adjusted duration for when those power-ups are active. And then we're going to stop any lingering old movement actions by doing an enemy dot remove all actions. And then we're going to establish another move action. So move action equals SK action. And these are things we've done before. Dot move to, we're going to set the Y with the duration. So for the Y, we're going to do the minus enemy dot size. And again, if you watch the height, I made the same mistake last time. If you watch the previous tutorial, we've already kind of handled this, but now for our duration, it's going to be the adjusted duration, right? Because we have different variables we need to account for, we need to make sure in our logic that we're handling them appropriately. Then we're going to have our remove action equals SK action dot remove from parent, and then our enemy dot run, we're gonna have our SK action dot sequence, and we're going to have an array once more. It's going to use the square brackets, move action followed by the remove action. So this is essentially going to allow us to apply new speed. Okay, the next one we're getting in trouble for is the restart score timer. So let's go ahead and create that function. So let's scroll down after our new enemy speeds function. Let's create another function called restart score timer. Don't need anything within the parameters here. We're going to add our brace, but essentially we're going to restart the score timer applying any game time modifications. So our score timer dot invalidate is the first thing we want to do, which is going to stop the old timer. Then we're going to have our score timer equals timer dot scheduled timer with time interval, and we're going to do the repeats one just like we did last time. So with the time interval, we're going to set this to be 1.0 times our game time modifier that we're adjusting with our power-ups. Our repeat is going to be true, and we can get rid of that block once more. Make sure you get rid of that apostrophe after true as well. But then I'm going to add a brace. I'm going to do underscore in if, and we're going to do the opposite. So our exclamation point self dot game over, and another brace self dot score plus equals 1, our self dot update score label. So this will allow us to essentially like really make sure that when we are increasing the speed of the game, we can also increase the score timer of the game. And when our power up runs out, it's going to reset it. So it's going to say, okay, I'm going to look at what the game time modifier is every time my restart score timer is triggered. So when we pick up the power up, we're adjusting that number. We're calling upon this function, so now it's going double speed. When the power up ends, we're reverting that number, then calling upon this function, which is 1.0 times 1. So it's kind of resetting it back to default. All right, what is our next error? Oh, I think this one needs to be enemy speeds is what we had called it. Okay, cool. So we could go test out our game, except for one thing. We haven't actually spawned the power-ups yet. So what we need to do is go to our start game, and this is where my good friend Command F comes in. If we know our function is function start game, we can just simply type it out, and we can find where we need to go. So if you're ever lost and I'm saying, hey, let's do the function start game, let's change something within here, Command F will really help you out. Otherwise, for me, it's on line 159, right under the setting up of the UI. All right, and with our other timers, let's go ahead and reference our PowerUp timer that we created before, and we're going to invalidate this one as well. Whenever we start the game, we want the timers to reset back to 0. All right, and after our score timer here, so there should be a couple braces. If you ever want to double click outside of the braces, we're going to now have our PowerUp timer equals a timer scheduled interval repeats. Getting used to this. So with the time interval is how many seconds before they reset. For testing purposes, maybe I'll set this to be 10.0. In my example game, I had this about 20. You can change your balance. Our repeats to be true. And we can go ahead and get rid of that extra placeholder. We're going to go ahead and add our brace here. And what we want to do is basically say, well, as long as the game isn't over, go ahead and spawn a power up every time that timer is running. So we're going to do our underscore space in, and then the next line, if, exclamation point, self dot game over. You'll notice that a lot of our game logic repeats because we need to make sure we're dotting our I's and crossing our T's, as long as the game's not over, spawn the power-ups. If we didn't have this, then it would just be spawning at random almost, right? Self.spawn power-up. Now let's go ahead and create that function to spawn the power-ups. We're going to go ahead and leave that brace. And we're going to create function spawn power-up. T parameters. Let's go ahead and add our brace. And we're going to do the same thing we do with the enemies, is basically in between a range of X values randomly, they're going to sprinkle from the sky. We're right by the spawn enemy. Even if you wanted to copy this random X, let's might as well do it. Save some time, right? This is going to allow us to spawn it within the random X position within the screen bounds. And then we're going to have our PowerUp types. So PowerUp type, which is going to conform to the PowerUp type with the capital P. This is our variable to hold the chosen PowerUp type. We're going to have our chance. Because I want these to be completely random, I'm going to have this equals int dot random in, and I'm just going to choose a range from 1 to 3, right? We have 3 power-ups, and this is going to essentially assign a random number between 1 and 3 to determine the power-up type. So we're going to be choosing that with a switch called chance. So in the first case, if it chooses the number 1, I'm going to do 1 colon, the power-up type is going to equal the dot speed boost. Our next case is going to be the case of 2. And for this power-up type, we're going to have it equal the dot slow enemies. And then for case 3, power-up type is going to equal the dot shield. So all of these have a 33% chance of spawning. It's perfectly random. If you had 4 power-ups, right, you would just have this be 4 cases with the range of 1 to 4. Oh, I'm sorry. We actually don't want case 3, we want default. That's right. For this case, we definitely need a default value, but this will still choose either 1, 2. Default in this case is basically just 3, which is why in my head I created the third case. Now we need default for this case. All right, outside of this brace here, we're going to go ahead and have our let power up. And this is going to equal our power up. And within the brackets, we're going to include the one with the type, which is our power up type. And this is going to create that instance. And we're going to reference our PowerUp.position. This is going to equal a CG point. And we're going to use our X and Y. So the X is that random X we had above. And then the Y is going to be the size dot height. And this is going to allow it to spawn at the top of the screen. We're then going to need to add the child, and this is just going to be the PowerUp, which is going to just essentially add the PowerUp to the scene. Next, we need to include a move action. So let move action, because we want it to kind of fall down at a consistent rate. This is going to equal an SK action dot move to Y, move to the minus PowerUp dot size dot height. Again, a lot of repeating things, and we're going to have these fall over 4.0 seconds. If you want to have them match the enemies, be super slow, super fast, you can adjust the time it takes them to go from top to bottom. I'm going to have them a different speed of the enemies, because if they spawn with an enemy, it might be really hard to collect them. Then I'm going to create a remove action, right? We don't want to have our kind of things be falling into oblivion forever. And for that, we're going to have the SK action remove from parent. We're going to remove it when off screen. So after the 4-second duration, which it takes to get from top to bottom, it'll then remove it. How do we do that? Well, we're going to go ahead and run this thing. So PowerUp.run. Again, you'll see a lot of repeated concepts here. So this is going to be SKAction.sequence. And we're going to have the move action first. Once the move action is done, we're going to do the remove action. Oh, sorry, for this type, we're going to be doing the lowercase PowerUp. If you got that error as well. My apologies. So something we're going to also need to be taking care of is in our function of setup player, where we have all of our kind of logic for the physics body. We're going to make sure that on our contact test bit mask here, so this one it's currently equaling 2, we're going to have this with a kind of or statement. So we're going to have here instead is our physics category, that Swift file we created before, dot enemy. And then we're going to use the or, so we're going to use that kind of straight line. We're going to do the physics category dot PowerUp. We want to be able to have kind of different conditions as well as detect a collision for both those different cases. The enemy will kill us and the PowerUp will give us power. All right, cool. Because we're also changing some things with the movement of the enemy, let's go ahead and change some things in our spawn enemy. All right, let's go ahead and adjust our move action, because remember we are changing the speed at which the enemies fall. So in our move action, we have SK move to Y enemy sight. We need to adjust the duration, and that's just going to be the adjusted duration we had above. So just like with before, we're going to create a base duration. So base duration. Going to be a time interval, and we're going to set this to equal 3.0, which is the default from top to bottom. We're going to do our let adjusted. If you want to save some time, copy and paste, feel free to do so. And then this is going to equal the base duration divided by enemy speed modifier. And this is going to adjust the duration based on the PowerUps. And in our didBegin, which essentially handles the collision detection logic between game objects, we have our first body, we have our second body. We're going to change this up a little bit because we're now including the physics category for those different conditions. So because we kind of need to rethink our detection because of our physics category, I'm just going to delete everything we currently have within the function. And we're going to set it up pretty similarly. So we're going to have our first body, and this is going to equal contact dot body A, and that's it. Then we're going to have our second body equal contact dot body B. So A is our first object in the collision, and B is the second object in the collision. So first we're going to handle the PowerUp collection. So if first body dot category bitmask equals physics category dot PowerUp, we're going to do the double straight lines here. So shift with those lines. Second body dot category bitmask equals physics category dot PowerUp. And then add our brace if let PowerUp equals first body dot node as question mark PowerUp. We're going to use our capital U there. Use our double question mark to second body dot node as question mark PowerUp. Then add a brace here. We're going to then apply the PowerUp, which is going to be the PowerUp with the lowercase p. And so this is going to apply the collected PowerUp. We also need to prevent a crash by ensuring that the PowerUp is still in the scene before removing it. So if PowerUp dot parent exclamation point equals nil, add our braces here, PowerUp dot remove from parent, right? It's just like in Mario when he collects the mushroom. We need to make sure that once he's collected it, we are removing it, but we have to make sure that it's still in the scene first. Cool. After our if let here, so I think that's 2 braces below, we're going to go ahead and return. We're going to exit the function since PowerUp collection doesn't cause a game over. Cool. We still want to be within this function because we're not quite done yet, because we still need to handle the enemy collision with the player. Right? We've handled the collision with the PowerUps, but not with the enemies yet. So if first body, we're going to use our brackets this time, category bitmask equals physics category dot player, and do the double ampersand for and the second body dot category bitmask equals physics category dot enemy. Outside of this, we're going to add another or statement. So then we're going to add brackets again. First body, we can see that the AI has a good idea what we're trying to do. First body dot category bitmask equals physics category dot enemy ampersand second body equals physics category dot player. I was getting ahead of myself. I was like dot player. So essentially, we need to make sure if the first one's the player or the first one's the enemy, both cases are kind of handled properly for the detection. Oh, I forgot the dot category bitmask here. I was typing too fast. I should have just did the AI autofill. I had it all to begin with. We're going to handle if our shield is active first, right? So that's the first thing we want to check. So if the player has the shield, they need to be able to soak the hit. You can even use a print statement if you want to have the debug log message. Otherwise, we'll just be setting the shield active to equals false. Still within this if statement, we want to then remove the shield visual effect. If let shield glow, lowercase I believe, shield glow equals player dot child node with name shield glow. That's what we had called it. We're gonna add a brace here, and we're gonna say let flash equals, and this is gonna add like a little flash action to kind of like indicate that we've lost the shield. Dot sequence, we're gonna add the actions here. So we're going to need to include an array because we're gonna have a whole bunch of different things happen. The first one is an SKAction.fadeOut with duration. We're gonna make it really quick, so this is gonna be 0.1. Because it's an array, we're going to use a comma to separate all these different actions. SKAction.fadeIn with duration 0.1. And then fade out one more time. What the heck is going on here? Little curves. SKAction.fadeOut. So this is kind of going to have it flash. Going to fade out, fade in, fade out. This one does be 0.1 as well. Going to include another comma because now we want to have the SKAction.remove from parent. Inside of these kind of brackets here, we're going to have our shield glow run. We're going to have that flash. So we've kind of established what that sequence is going to be, and then it's going to run that sequence, which is going to kind of be that disappearance animation. Now we need to remove the enemy that collided with the shield. So if first body dot category bitmask equals physics category dot enemy, add a brace here. First body dot node question mark dot remove from parent. Then we have an else statement here. The second body dot node question mark dot remove from parent. Then we're going to go ahead and return because we need to get out of this if let statement. Okay, and let's hop out of this if shield is active. So in the cases that we don't have a shield to protect us, so when we're hit without a shield, we're going to trigger game over. I'd also include a print statement here, just say player hit, right? Just so we know, just in case there's any funny business. And then we're going to have our game over equals true. So this is going to flag the game to be done. Our game timer question mark is going to be invalidated. Score timer, exact same thing. And then our power up timer also needs to be turned off. And we're going to show the game over. All right, cool. We're not quite done yet. We need to go to our check collisions. If you want to go ahead and search for this or just scroll down a little bit, we need to make sure that we're ignoring the player and background and power-ups within the collision check that we have here. So where we have our node as, SpriteNode, we're also going to be adding a comma, enemy.physicsBody, question mark, dot category bitmask. We're going to have this equals space there, equals physics category dot enemy. And we have our distance here, which should still be great logic. The only difference is we also need to be handling our shield active within the check collision. So under the distance, we're going to add another if statement, if shield active. We're going to set that shield active to equals false because it's going to observe a hit, and we're going to return, which is going to prevent a game over. And just because we need to also invalidate our power up timer, and see that here. Alrighty, and in our restart game, we'll also need to restart the enemy speed. Otherwise, if we somehow die with like a power up, it might kind of glitch it out. So let's go to where we have our game over here. And just above that, let's have our shield active equals false. Let's have our enemy speed modifier equals 1.0, as well as the game time modifier. Let's set that to be 1.0. Alrighty, we should be able to go ahead and test our... Oh, cannot find PowerUp in scope. Oh, this is supposed to be capital P PowerUp here. Sorry about that. And it's not Nile, it's the nil. we don't have West Nile virus. Okay, well, let's go ahead and run our app now that we fixed those couple mistakes. Thank you, Exco, for pointing those out. Alright, let's go ahead and start our game here. Bulletstorm Revenge 3.0 looking great. So I believe we had set it to be 10 seconds. What if I set it to be 100 seconds on accident? So we should have seen a power up here. That's quite odd. We might need to go back and double check something real quick. So let's go ahead and pause our app. In our start game, I chose the wrong autofill. My bad. Okay, so it's the timer.scheduled. See, I was going too fast. Timer, scheduled timer. But this would be 10.0. I got cocky. I got ahead of myself. You know, that happens. But that's why we test things out, so we can see the mistakes that we've made and then rectify them. Alright, our build has succeeded. Let's go ahead and test this out. What do we got coming up here? Another shield. Wonderful. Hit things. The shield goes away. Nice fade animation. That's cool. Alright, 20 seconds. Okay, we have this slowdown coming up. Let's go ahead and collect that. Oh, look how slow this... Everything is spawning. Oh gosh, okay, it kind of jumps after a few seconds. We might need to fix that power up. Let's go ahead and teleport over here, grab the speed boost. Let's see. Oh my goodness, everything's falling so fast, but the score timer is going really quickly, which means we are earning score a little bit faster than we were before. We can see that these power-ups are working pretty much as intended. Oh, we had a little bit of like a hiccup in the simulator, so it caused me to crash, but for the most part, we should be good to go with this new game logic. It is adjusting the enemy speed. It's adjusting the time. Our shield's working properly. You can't apparently code in to have skill at this game though. I'm showing you that one. Let's go ahead and stop running our app. So there might be a few tweaks we might have to do to the PowerUp logic, but for the most part, our game is working really well. So today we explored adding different power-ups to our game. We had one that increased the speed, slowed down the speed, as well as one that provided us with a invincibility shield. And these are going to enhance your user experience by so much. So something I would encourage you to do is to look at the examples that we made today and apply them to your own game, right? Whether you're doing a Bulletstorm game like this, or just how to handle the different collision detections, as well as how to augment the game state for a better and more clean user experience so people can have a lot more fun and more dynamic fun in your game. Like I said, in my game, I'm currently collecting these things and they're applying instantly. Maybe in yours, you want to have like a kind of gathered power-up system where every time they get maybe a power-up, they can press on a button on the screen and they can activate that power-up whenever they choose to. And that adds even more dynamic gameplay. In our next series, we're going to be looking at our user experience a little bit more and kind of handling the game over state a little bit better, as well as we're going to be adding some AI enemies in the sense of we're going to be creating enemies that have different gameplay logic than just the ones that are currently raining down from the screen. We're going to be creating some that actually track where the player is and try to intentionally take them out. So I'm really excited to be continuing this series of SwiftUI game development with using SpriteKit, and I really hope to see you in the next one. Otherwise, dream big, code bigger, and have an amazing day.